The overall goal of this procedure is to produce thermoplastic composite joints for basic mechanical testing using simplified energy directors, rapidly defined optimal welding parameters, and displacement control for consistent weld quality.
This method helps answer key questions in the area of joining of composites, such as what is the strength that can be expected from a welded joint in thermoplastic composites.
The main advantage of this technique is that it produces consistent, high-quality welded coupons after fast definition of optimum welding parameters.
For this procedure, have a microprocessor-controlled ultrasonic welder that can operate at a constant amplitude. The welder must output process data, such as dissipated power and displacement of the sonotrode versus time, to a computer. This demonstration uses a custom-built jig designed to accurately position and clamp single-lap shear samples. Turn on the ultrasonic welder and log into the computer. Before each experiment, log the following parameters: room temperature and humidity, the welding setup reference, the sonotrode type, the sample number and materials, the width and thickness of the top and bottom samples, and the thickness of the energy director. Start the data acquisition software and open a new session. This demonstration uses a 40 mm diameter cylindrical sonotrode. The next steps are to add the samples and the energy director. First,